1-1. Okay, let's kick off. Thanks a lot for coming over. I hope you enjoy EFCC, even though it's pretty hot over here. My name is Marcin. I'm co-founder of RedStone, which is the fastest growing Oracle on the market right now. And I'm going to talk about tackling the Oracle extractable value problem with a design that works at scale in production. So to kick off, giving you a sense where we are right now, liquidations are a nice fight. I believe you've never participated in nice fight. If you had, there's chances you wouldn't be here today, right? So as you know, there are casualties in knight's fight. It's sometimes was needed in medieval ages. We also see conflicts nowadays. But in general, the principle is usually like less conflict, less casualties, the better EV for everyone. So it's not necessarily the situation we would like to keep having. Why is it a nice fight? So today's situation is that when there's a protocol and there's a liquidation transaction, usually the bots are fighting to bribe the validators to get the transaction included so that they can capture the liquidation. And basically, it's a bidding war. The result of that is protocol gets nothing from that. There's a liquidation bonus that the protocol gives, let's say 10%, depending on the design, depending on the asset, and so on. Gas is wasted because those bots are essentially like fighting to get the slot, so they're wasting the gas. As a consequence, they spam a network. So if it's a network that is a world computer, like for example, Ethereum strives to be, then probably it's not necessarily the transactions we would like to have on the network in general. And the risk control is outsourced from the protocol to the, let's say, validators market. Hence, the current situation is not a system. And DeFi protocols are missing out on billions escalated over a longer period. So we have a better way to handle MEV. And the proposed solution is, okay, maybe first how Oracles works. So we have two major systems right now in Oracles. One is the pull Oracle, the other one is the push Oracle. The pull Oracle means that whenever a user is interacting with a protocol that requires an Oracle update, the user himself would update the price on chain. I tend to call it on demand. Only when there is needed a price update, you're going to update that. It's a newer, fresher system, less adopted. So the one that is used by Aave, Compound, Morpho, Liquidity, and many other protocols is the push Oracle, where you take the data and you throw it on chain in intervals, usually time interval and deviation threshold. Deviation threshold means the maximum deviation that the on-chain price should deviate from the freshest price that is available on the market. So imagine, for simplistic words, imagine Bitcoin USD right now trades at $1,000, and we have a deviation threshold of 1%. So now we update on-chain $1,000 is the price of Bitcoin. If it moves to 1,002, for example, the new update is not going to be triggered. Everyone who is using that price is accepting inherently that it can be wrong by 0.5%. Only when the 0.5% is met from the previous update, the new update is going to be delivered. And this is the model that right now 90%, maybe 85% of DeFi uses right now. And most importantly, the big protocols are using Aave, Compound, and as I mentioned, the blue chips. So we propose, and majority of OEV solutions in the market work that once you have the price updated on chain, then you do the OEV action or any action. Our approach is that the auction should happen before, because then you have no delay. So the auction is happening off-chain with no blind guessing, no gas wars, and no duplicate transactions clogging the network. So the transaction that is updating the price is already containing the result of the bidding in the auction for having the priority to liquidate a specific position. And in general, OEV shouldn't be just a revenue tool. It is a missing piece in DeFi, in my opinion, because it turns noise into order. It gives the protocol and the wider DeFi ecosystem another tool for managing how the system is operating. So some principles that, in my opinion, are crucial when you're designing any OEV system. First, it has to be fast. Liquidations are a very, very sensitive part of the DeFi workflow flow. Because if you delay a liquidation, it can turn out that the position is underwater with that the position is underwater in the sense that the protocol is accruing bad debt. Because, for example, the price of an asset is plummeting so much that you didn't manage to liquidate it within the reasonable threshold, and then no one wants to close that position because it's unprofitable to close that specific position. So the OEV system should be fast. It should be easy to adopt. So we have battle-tested codes, like an example, Aave v3, Compound v2, and so on and so forth. So we do have a lot of systems that work at scale, and we know hacks happen. Like usually, I would say every quarter I hear about a bigger hack. So in order to omit them, you should probably try to adjust to what's working and incrementally improve that. So the OEV system that doesn't require any update from the protocol is a good one. It should be safe, so it shouldn't hinder the security of the protocol and the flow from the get-go. Permissionless and open, so liquidators should be able to join the bidding process, and it should be an open process to do so. And it should be cross-chain by default. The majority of OEV is happening on Ethereum nowadays. But as we see, for example, Robinhood announced their L2 using Arbitrum stack on Monday. There's Base, there's Arbitrum, there are many other networks, EVM, non-EVM, that are growing. And this problem is present in all of them. So the solution that you create should be cross-chain by default. It's not like optionality, in my opinion. So how the OEV works is that RedStone detects the price update that could trigger a liquidation off-chain. So imagine, again, this Bitcoin traded at $1,000, and right now it trades at 992. And the update deviation is 1%. So as I was telling you, a regular push oracle would not update that on-chain, even though the position is already underwater. Why? Because Oracle, without OEV, is not aware that this new price would cause the liquidation. As it is of today, any other solution thinks in the way that only the on-chain environment detects the liquidations, right? And here, imagine there is a price of 992. So the one that could cause a liquidation, but in regular system wouldn't do so, would wait until it goes to 990, right? So RedStone detects that price off-chain. Usually it's on Binance, OKX, Bybit, any other centralized exchanges, because that's the most of the volume. Like, they are usually the quickest to have this kind of a price discovery for very liquid assets. Then we have an auction that runs off-chain with Fastlane, which is a specialist in MEV. They've been very long in the Polygon ecosystem. Now they're also in Monad. And they created a product called Atlas that allows for this atomic auction. And the Atlas product gives you an ordered list of bids of the liquidators that want to take part in this process. So the liquidators are bidding for getting a priority pass and access to liquidate this particular position. And then on-chain, RedStone Relayer, which is this technology that throws data on-chain, would deliver the price update together with this list of bids. And the Atlas execution uses try-catch loop to proceed bids in order on-chain. And then the liquidation happens. And now the kicker. I believe this is the most important slide in the whole presentation. The whole process takes maximum 300 milliseconds. And to give you like comparison, in 1 second we have 1,000 milliseconds, right? So it's 0.3 of a second. So for a man brain, I think it's already impossible to comprehend. I think we have like 300 frames per second or something like that that we can detect as a human eye. So it's extremely fast. And for a majority of the ecosystems, this is faster than a block time. We created also RedStone Bolt, that is the fastest oracle on the market for MegaETH, that updates price feeds on chain up to every 2.4 milliseconds. Over there, we need to decrease the latency over here, but for majority of the networks, it's faster than the block time. And if there is no valid bits in the process of this 300 milliseconds, the system gracefully falls back to regular price update. So imagine there are no bits, or no bits was like worthy of the liquidation. After 0.3 seconds, a regular update would happen on chain. And in the example I gave you, this 992, that's the moment the auction would happen. And if there is a bidder that wants to liquidate that and pays for the price update priority, then the update on chain happens. So a byproduct of this OEV design is that you have more accurate data on chain. You found a new person who is willing to pay the gas for updating transaction on chain and making the on-chain data even more accurate. Because the biggest problem of push oracles is who pays for the gas, right? Because it's public. I mean, once it's on chain, everyone can use that. So over here we found a new player, like a liquidator, that is incentivized to update data on chain the moment there is a profitable liquidation to happen. If there is no one, like imagine this liquidation is like very small, like $1, then probably no one would, take part in this bid process. So an update will not happen. And then if Bitcoin keeps on dropping at 990, the regular Oracle update would happen, and then regular process of the MEV on chain would happen, right? So the system I'm describing over here has already gone through Venus protocol. I think top 4 lending protocols in the DeFi ecosystem. It's the biggest one on BNB chain. We've run it for 30 days to observe the results. And we recaptured directly for the protocol $6,000 in total liquidation volume of 165,000 and 90 liquidations in total, and 0 downtime. Because the auctions were happening faster than the block time, so there was literally 0 downtime in the whole process. It was invisible almost for the lending protocol of the users that it's actually implemented, which is very important in designing such a system. And literally yesterday, no, what's this? It's Wednesday, sorry, 2 days ago. If you go to Venus forum, they voted in favor of enabling RedStone OEV on every market of theirs on Unichain. And if that gets proper numbers, we're going to roll it out on all of their markets on our chains. And we are in talks with all the other serious lending markets on the market. So key takeaways, the system worked out of the box, no code changes for Venus. Venus did almost 0 work, they had to look into the design naturally, but the workload was on ours. Liquidators didn't need to change their infrastructure. RedStone handled sequencing, execution, fallback mechanism seamlessly. And this was real value, captured safely and predictably. And the money that was got over here can be redistributed as Venus wants. So it can go back, for example, as incentives for borrowers, because usually this is what lending market would like to incentivize, or it can go to their treasury or any other activation they would like. So we redistributed the flow, the money that was leaking out of the system. And integration is that simple. The heavy lift is on us, on RedStone. So the only thing you have to do is actually use RedStone price feeds on the lending market or a DeFi protocol, and give us a heads up that we should turn on the OEV on a particular feed on a particular network, or all your feeds if you prefer so. And then we handle all the legwork out there. So who wins? First, the protocol wins because they have better liquidations. As I told you, they don't have to wait for this deviation threshold. We sometimes tell them, hey, we created a push oracle with 0 deviation threshold. It's simplistic because it doesn't mean that we always update with 0%, but from the perspective of a lending or a DeFi protocol, what is important is that it liquidates as fast as it's possible, the moment it's present on chain. So they capture additional value with increasing the security of the protocol. The users are more happy because there is less slippage and fewer surprises. And usually when we talk with those lending protocols, they perceive it as a new stream of value, but they don't want to take it to treasury, majority of them. They're like, hey, let's make it more competitive. So we want to stream all the value, for example, to increase the attractiveness of borrowing or lending or any other activation in the system that is happening. And the liquidators are also happier because they don't have to go into the MEV bidding wars because over there, at least on Ethereum, it's many times like some deals and cooperating with the large players that are having the majority of the MEV infrastructure on a given network. Over here, it's like open access, no whitelist, no collocation. It's like just a bidding. So it's more of a process of understanding like what is the highest bid I'm willing to pay to still make money out of getting the priority for liquidating that specific position, right? And as mentioned, it's already available on BNB chain, and now we are rolling it out as we speak. Our engineers are working on it on Unichain. Soon, we already have signed deals with Hyper EVM, so the hyperliquid chain, Base, Katana, and a couple of more that I cannot reveal yet. But many of them perceive it as a new system that increases the efficiency of the market. Any EVM-compatible chain for us is seamless. Like a rollout would take between two days to 2 weeks, depending on how the EVM actually works. And liquidator boards are open source, so anyone can join. And another interesting positive externality is that RedStone right now works a lot with tokenization platforms, RWAs. We are the major oracle for Securitize. So we provide BlackRock Biddle, Apollo Acred, Vanek Vibil, and many other tokenized products. And for them, the big problem is the liquidity on-chain, because these tokenized products don't have on-chain liquidity. And via making the liquidation system more efficient, you can also experiment. Right now, we are talking about that with Euler, about making the capital efficiency higher so that you need less capital for liquidation because it's more predictable. You don't have to fight on the MEV auction. You have just better understanding how is going to be the outcome. It's still somewhat probabilistic, but it's getting more and more deterministic in that sense. Yeah, so this is all on the OEV part. If you have any questions, we still have 2 minutes, and I believe soon Vitalik is speaking on the main stage, so I also don't want to keep anyone too long. But thank you very much, and yeah, if there are any questions, happy to take them. Okay. The question is whether we take a cut. Yes. I mean, at the end of the day, it's an infrastructure we've built and we are running. So there is some maintenance cost to all those actions and whatsoever. Every single deal with the protocol is one by one assessed because the liquidations on Venus with a couple of billions of dollars on BNB chain is going to be a different deal than on Unichain, where they have right now, I don't know, like 100 million roughly. So it's a one by one conversation. The current, let's say, equilibrium, what we observe on the market is roughly 65% to the protocol and whatever, and the rest going to pay out the infrastructure and part going to the oracle. And then naturally it can go usually higher, like 70% to the protocol and whatsoever. So it really depends on step by step. Because from the protocol perspective, the change is, hey, now I get nothing. And out of the blue, I can get 65% of this redistributed flow over here, right? So this is like their perspective. Yeah. Okay.
I'm not sure I fully understood the architecture. So you're an Oracle company, right? So you've got your own nodes, because at some point you said there's no collocation, but you're collocating, presumably, your own nodes.
Collocating to what?
To the like Binance to get closer to the price updates.
Well, we do collocate for specific chains, like for example MEGAETH. We collocated our nodes in their sequencer so that we can update every block. But when you're talking about, I don't know, Ethereum or even BNB chain, where it's, let's call it 300 millisecond, you don't necessarily have to collocate next to Binance to get that accuracy and speed. But sometimes we do collocate.
But do you plan to let anyone run nodes, RedStone nodes, whatever that would be?
Yeah. Right now, Kaiko, I think Kirok, Alchemy, and a couple of other data providers are running RedStone nodes. We have a running guard program. So if you type in internet RedStone guard, the first batch was announced, I believe, in March. And I think the on-rolling for the next batch is right now open. So yeah. Alrighty. Thanks a lot, guys, and hope you enjoy the rest of UCC. Cheers.